formation include three processes: glomerular filtration, selective reabsorption, and secretion. What factors influence it? Why does the urine increase after drinking plenty of water and decrease when sweating a lot? What change may be in urine when losing massive blood? Why? To settle these questions, we'll learn the regulation on renal function. The renal function is under autoregulation, neuroregulation, and humoral regulation. We introduce autoregulation first. If solute concentration in tubular fluid increase, osmolarity increase, water reabsorption decrease, thus the urine decrease. This phenomenon is called osmotic diuresis. In diabetes, blood glucose is higher than the renal glucose threshold. Not all the glucose filtered can be reabsorbed, appear osmotic diuresis. 20% mannitol leads to massive urine, also due to osmotic diuresis. We've learned that the reabsorption in proximal tubule always accounts for 65 to 70% of the glomerular filtration rate, being called glomerular tubular balance. It's due to the structure of nephron. If glomerular filtration rate increases, the pressure in peritubular capillary is low, where the colloid osmotic pressure is high, so the reabsorption increases. It benefits to prevent great change in urine volume. Kidney is only under the regulation of sympathetic nerve, which releases norepinephrine. Norepinephrine binds with alpha receptor to contract renal vessels to reduce the blood flow. The glomerular filtration rate decreases greatly due to the more obvious contraction of the afferent arteriole. Norepinephrine binds with beta receptor in granule cells to increase the releasing of renin through RAAS, promotes the reabsorption of sodium chloride and water, thereby reduce the urine. Norepinephrine binds with beta receptor to promote the reabsorption at the proximal tubule and loop of Harnow. Therefore, sympathetic excitation can lead to the decrease of urine. Two hormones regulate the formation of urine mainly. The first is antidiuretic hormone, short for ADH, also known as vasopressin. It's synthesized by supraoptic and periventricular nuclei in hypothalamus, then transported to store in the posterior of pituitary gland. The receptors include V1 and V2. V1 receptor is located in vascular smooth muscle, which can include blood pressure. V2 receptor is in the peritubular membrane of collecting duct. If it binds with ADH, water channel on the lumen membrane increase to promote water reabsorption. The release of ADH is affected by many factors. The most important one is plasma crystal osmotic pressure. The receptor in hypothalamus is most sensitive to crystal osmotic pressure formed by sodium chloride, but less sensitive to glucose and urea. Sweating a lot, severe diarrhea, vomiting, and high fever lead to more water loss. Plasma crystal osmotic pressure increase, ADH increase, increase water reabsorption, thus urine decrease. Drinking 1 liter normal saline or water. What's the change in urine? From this picture, we can see that the urine volume almost doesn't change after drinking normal saline, but increase greatly after drinking water. Why? After drinking water, water absorption reduced plasma crystal osmotic pressure, then ADH decreased, water reabsorption decreased, and the urine increased. This is also known as water diuresis. The next two factors regulating the release of ADH is blood volume and arterial pressure. If blood volume decreased 5 to 10%, volume receptor in large vein and right atrium would be inhibited. If arterial pressure decreased 5 to 10%, baroreceptor at aortic sinus and aortic arc would be inhibited. Both of them make the secretion of ADH increase, so the urine decrease. In addition, nausea, pain, stress, and hypoglycemia can promote ADH secretion, while ethanol inhibited, so the urine would increase after drinking alcohol. Aldosterone is a steroid secreted by the adrenal cortex. It enters the epithelial cells, binds with receptor, then enters nucleus to influence the transcription and translation of DNA to produce new proteins, including sodium channel in the lumen membrane, and then in mitochondria, or sodium pumps on the peritubular membrane. So, the main function of aldosterone is promoting the reabsorption of sodium and water, and the secretion of potassium at the distal convoluted tubule and collecting duct. Aldosterone plays an important role in keeping high sodium and low potassium in extracellular fluid. Therefore, two factors regulate the secretion. The first is the concentration of sodium and potassium in the blood. If sodium decreases or potassium increases, aldosterone increases to recover the concentration. The second is RAAS. If blood pressure and blood volume decrease, renin secretion increases through RAAS. Aldosterone increases to benefit the recovery of blood pressure and blood volume. Blood pressure or blood volume decrease leads to renin secretion through 4 ways. The stretching of afferent arteriole decrease. Sodium in tubular fluid decrease make microdancer excited. Sympathetic nerve excitation. Epinephrine or no epinephrine. All of these can lead to the secretion of renin. Now, let's do a summary. Renal function is under autoregulation, neuroregulation, and humoral regulation. At normal, the urine is stable relatively through autoregulation. When the homeostasis of internal environment is destroyed, sympathetic excitation and humoral factors are conducive to recover it by influencing the formation of urine. That's all for this class. Thank you. See you.